Hey guys, this is going to be your notes for section 4-5. And this is your intro, so I'm just going to give you an idea of what we're going to be doing. So remember, this whole chapter has been about creating lines. So up until now, we've had perfect lines. But in the real world, we get this stuff data. And you should know what data is by now. Data is just comparing to an input and an output. Very often, data does not line up in a perfect line, but it's very, very close. So we use a line to represent it. You saw that in the last one when we were doing lines of best fit. Now we are going to use what's called linear regression. I'm not going to get into it too much, but linear regression is just a computerized method to create a line of best fit. Okay? So now, and obviously this will look much better if you get this from the book. Now, a line of best fit. All a line of best fit is, if we have all of this data like we saw last time, we want to get a line that is as close to the data as possible. If I had a data set that looked like this, I would be hard pressed to say that would be a good line to represent it, correct? That might be one of the lines of worst fit. We are looking for the line of best fit. So it might be something like that, okay? Well, your line of best fit and my line of best fit might be something different. That's why we use linear regression. There's a mathematical operation that gets us to our line of best fit, and the line of best fit is just the y equals mx plus b that is the closest or the best for all the points. So it's the y equals mx plus b that best represents the data. And so there's no argument about what's best. We use linear regression. Makes sense? This is the method to get the line of best fit. That's the end of the day, but you guys got to stay here because we're online. So after you get your line of best fit, now it depends how the data looks. If I have data that's lined up really well, my line of best fit will represent the data very accurately. So if I had a data set that looked like that, and I have a line like this, I would say that fits it very well. If I had a data set that looked something like this, and sorry if you can't really see up to the top very well, but we can see that it's going up. So we would have a line that looks like that, but this line doesn't really represent the data well. It's the best line I can come up with. It's the best line anyone can come up with, but it's still, the best line will not represent the data well. Sometimes it will, sometimes it won't. The correlation coefficient is a number that tells us how good our data fits the line, or how good our line fits the data. So, linear regression, how we create a line of best fit. Line of best fit, it's a line that represents the data. Correlation coefficient is a number that tells us how good our line of best fit is, how best it is. Okay? And then causation and correlation, I'm going to wait until we actually get into the rest of the chapter to fill that one out, okay? So right now, to start off this section, you need to understand really line of best fit and correlation coefficient. Those are the two big things I want you to come out of this with the vocab for, and then how to use them. So linear regression, the method to make the line of best fit. The line of best fit is a line that represents a scatter plot, data just out there. Correlation coefficient is a number that tells us how good our line represents the data, how good it fits. Okay? So that is your intro to 4-5.